Hello everyone. So today we will be solving lead code problem 142, that is linked list cycle 2. So we are given the head of a linked list and we have to return the node where the cycle begins. If there is no cycle, we should be returning null. So let's move over to our drawing explanation and see how we can solve this. The first approach we can take help of is a hash map. So what we will do is we will first check if a node is present in our hash map. If it is not present, we will add that node onto our hash map. And if it is already present, then we will just return that node. It's as simple. So we would check if 3 is present in the hash map. If it is not, we would add it. If 2 is present, if not, we would add it. If 0 is present, if not, we would add it. If -4 is present, if not, we would add it. So as we see in -4, now we are getting back 2. So our linked list has a cycle. So the next time we would check, like we would come here, we would check if 2 is present in our hash map. Yes, 2 is already present in our hash map. So we would just be returning that node. So we would be returning 2 here. So it is very simple. Now in this case our time complexity would be O of n as we are looping through once, and our space complexity would also be O of n because of the size of the hash map. It would increase if we have got more numbers. Now another approach what we can do is we can use Floyd's Floyd's cycle detection algorithm. Now if we use this algo, our space complexity would be O of 1 because we would take just constant extra space. So in this algorithm, first what we will do is we will have two pointers, that is slow and fast. Our slow will move one step at a time, while our fast we will make it move two steps at a time. So at a point, our slow and fast will meet. So at that point, we will come to know that our linked list has a cycle, because if we are moving it one point at a time and if we are moving it 2 points at a time, so at a point when they would meet, we would know that our linked list has a cycle. Now to find the position, what we will do is we will move our slow back to our initial node. We would move our slow back to our initial node, and then we would move slow pointer one step at a time, and we would then move fast pointer also one step at a time. So now when they would meet, now when they would meet, we would return the position, because that would be the position. Now now when they would meet, they would be meeting here only. So we will be returning this position. So let's do a dry run and see how it goes. So we will have two pointers. One is slow, another is fast. So our slow will move one step at a time and our fast will move two steps. So now our slow will be here, our fast will be here. Our slow will be here in the next step. Our fast will be, it will skip this one as it is two steps here. Then our slow will be here, our fast will be here. So at this point, when our slow will be equals to fast, we will know linked list has a cycle. So after that, what we will do is we will we will initialize our slow back to our initial node. Like we would set our slow back to our initial node. So let me just remove all of this. So let's move our slow back to our initial node, and our fast was here. So now both of them will move one step at a time. So our slow will come here, our fast will come here. So at this point, At this point, we are getting slow equals to fast, and that is where we would come to know the position at which our linked list has a cycle, like the position from where the cycle starts. So this is about the logic. Now let's go over to lead code and try to code this. And this one will have O of 1 space complexity and O of n time complexity as we are looping through it once. But as we are just using constant extra space, so our space complexity would be O of 1. So let's go over to lead code and do this. So for the first approach, we will use a hash map. So let's do that. We will have a current pointer and we will iterate through that. So if our current is in our hash set, then we will return our current, else we would add our current in our hash set dot add, and then we would move our current to the next position. Yeah, so that is pretty much it, and we will be returning none if there is no cycle. So let's run this. Yeah, the test cases got accepted. Now let's submit it. So this is the way to do it with the help of a hash map. We will see the next way. So we will have two pointers, that is slow and fast. Then we will iterate through till we have a fast dot next, and we will move our slow by a single step and our fast by 2 steps. Now we will check if our slow is equals to fast. If so, then we will initialize our slow to head, and then we will, while our slow is not equals to fast, we will just move our slow and fast pointer both by single step. So our fast should be fast dot next. So while they reach the end of the loop, we would find, like, while our slow and fast will be equal, we would find the point at which our cycle starts. So we would return slow, and then we would come back of the loop. If we don't have a cycle, we would return none. Let's run this. Yeah, so let's submit it.